One of the concepts that we use quite often in our common day language, and which is an important concept, we don't use it as often in mechanics when we talk of motion. The concept is the same as when we use it for electricity and so on. Now, the concept is the concept of power. The concept of power, what we define as power, is the rate at which work is done. Let's try to explain this. If I have a crate and I have two people, Nerdy, and then I have the same block, the images look identical, and then muscle guy pushing that same block. And now let's assume that both of them push it the same distance. Now, if we have both of these doing it in a competition, you know that the muscle person, the muscle kid, is going to be able to get it here faster than the nerdy kid. And the way I drew them, a nerdy kid could be a muscle kid as well, of course. But that's not the point we're trying to get across. When I do this in person, when I have students in a class, I try to get two students, I choose them from their physique and to get them to push a table in the classroom or to push a table with someone sitting on it or something like that. Now, both are going to do the same amount of work since they're going to exert the same force to overcome the friction, and they're going to move it the same displacement. Now, however, the power exerted by one is different than the power exerted by another one. Okay, now what do we mean by that? We mean, actually, common day language, they're going to say this person is more powerful. Why is he more powerful? Because he's going to do the same work over a shorter amount of time. Now, that's what we call power. Work over time. Doing the same work, doing work over time that gives us power. The lesser the time, the more powerful the engine we use or whatever. For example, in terms of cars, the more powerful cars are going to get to particular speeds faster than other cars. That's a more powerful engine. So it is a smaller time for doing the same amount of work. That's what makes them powerful. Now, when people in the industrial age, when they started using machines, and that's when people start using the definition of power, so they had to compare machines to the actual tools that they were using at that time to do work. And the tools were animals, horses. So initially, when people started using units, they started using the unit of a horsepower. And we still use it these days for cars, for example, and big engines and so on. So a 1 horsepower is what we call 746 watts. Now, a watt is joules over seconds, and that's the unit for power. Joules over second, we call it watt, and it is the unit for power. Okay, you are familiar with the unit watt. It does not tell you how much work is done. It does not tell you how much energy is used. It tells you how powerful something is. When you buy, for example, light bulbs, when you buy a 25 watt light bulb or a 100 watt light bulb, it does not tell you how much each one of them is going to use in terms of energy. The 25 watt is less powerful than the 100 watt light bulb. Now, you might take both of them home and drop and break the 100 watt light bulb before using it at all at your home to use energy. So then the energy usage of that light bulb is zero because it didn't get connected. While this one, even though it's less powerful, if you connect it and you use it for however long it's going to last, you're going to use energy. Now, when you get your electrical bill at the end of the month, it's not going to be expressed in watts. Unfortunately, it's not going to be expressed in joules as well. It's going to be expressed in kilowatts hours. Okay, what's kilowatt hours? Okay. So it's watts times hours. That's time times power. Time times power. So that's the equivalent of joules. But instead of seconds, I have hours. So I will have smaller numbers. A watt times hour is actually equal to 3600 joules. 1 joule, remember, is a watt times second. So this is 3600 times as big. Just, plain old psychology, not to get you too upset when you see how much energy you use every month. And actually the kilo added to that, so when we have a kilowatt hour, it means 3,600,000 joules. Okay? So every kilowatt hour you use is 3,600,000 joules. Now, one interesting thing worth mentioning, I didn't speak of all the various units that we use for energy, but I'll mention one of the units that we use is we use calories and we use calories. And notice here, both of them are called calories, one with a small c and one with a capital C. In doing thermal physics, thermodynamics, chemistry, they usually use the 1 calorie with small c. When we get to food, we use 1 calorie with big C. And the difference between them, 1 calorie with big C is actually 1,000 calories with small c. And that's to tell you, you see, so psychologically you will feel better about eating 1,000 capital C calories for lunch than saying you ate 1,000,000 calories with small c for lunch. Okay, so it's the same amount of energy, but you are using different units to measure it. Okay, now